Hey guys, this is Miss Butcher, and this video is about composition functions. Now we've already learned how to do composition functions, the beginnings of it, so if you need to go back and review those videos, feel free to do that. But today we're going to do a little bit more complicated ones, and we're going to think about the domains of those when we do them as well. For this first example, f of x is 8x, and g of x is 2x to the 5/6 power. So we're going to find f of x times g of x, and we're also going to think about the domain of that. So if I just take 8x times 2x to the 5/6 power, all you need to do is multiply the 8 and the 2, get 16. And then we need to multiply the x and the x to the 5/6 power. Remember, you're adding your exponents. And 1 plus 5/6 would be 11/6. So the answer is 16x to the 11/6 power. We also want to think about the domain though. Domain. Because 11/6 and 5/6, we look back at the original problem, we look at the answer too. And both of those are sixth, and that's taking the sixth root. And we all know you can't take the sixth root of a negative number. You can't take any even root of a negative number. So our domain has to be 0 to infinity, where x is greater than or equal to 0. Now this time we're going to use the same f and g of x, but we're going to find f of x divided by g of x. So we need to take 8x and put it over 2x to the 5/6 power. So when you do this, you're going to do 8 divided by 2 is 4. And then when you do x divided by x to the 5/6 power, remember you subtract your exponents. 1 minus 5/6 is 1/6. So that equals 4x to the 1/6 power. And when you're looking at your final answer, you would say, okay, x has to be greater than or equal to 0. However, you also have to go back and look at your original right here when you plugged everything in, but before you simplified. We have division, and we all know that you cannot divide by 0. Therefore, 2x to the 5/6 power cannot be 0, which means that x can't be 0. So that's not our final domain. Actually our final domain is going to be x is greater than 0, but not including 0, because x can't be 0 either. Even though when you look at your final answer you don't see division, you've got to look at what you were doing before you simplified. And for this example, I've given you a new f of x and g of x. Now we're going to find f of g of -3. And this should be review because we have done this before. But the simplest way to do this is to work from the inside out. And so find g of -3 first. That means I'm going to plug a -3 in for x. And remember, when you square a negative, even though you punch it in your calculator without the parentheses, it's going to tell you otherwise. When you square a negative, you know it's positive. And 9 minus 1 is 8. So now you know that g of -3 is 8. Now we're going to find f of 8. So then we can go over here, plug an 8 in right there for x. 3 times 8 minus 4 is 24 minus 4, which is 20. So 20 is your final answer. And you just do it from the inside out. That way you don't have to plug a -3 into the g and then also plug that into the f all at the same time. That gets a little bit complicated. Just do it one part at a time. Alright, now here's a different type of example. I've given you a graph instead of the actual function written out. And I want you to find f of g of 3. So just like we did before, I want you to work from the inside out. I want you to find g of 3 first. And what does that even mean? It means what is y when x is 3? So when x is 3, we're going to go up to the g function, and that's this one. Sometimes it helps to highlight each one a different color. And we say, what is y? Well, y is 4. So we know that g of 3 is 4. G of 3 is 4. So now that means we're going to find f of 4. So now we go to the 4. When x is 4, we want to know what y is on the f function. So when x is 4, we go up to the f function, and we say, okay, now we know the answer. F of 4 is 3. 2, that's a 2. I can't read. F of 4 is 2. So the final answer would be 2. So here's another one for you to try. You might push pause and try it and see if you can do it yourself. F of 4. So we already know what f of 4 is. F of 4 is 2, because we did that right here with the blue line. The 4 to the f function, the y is 2. So now we need f of 2. And so you take the 2, and we're going still to the f function. And then the f function, the y is 6, so f of 2 is 6. All right. All right, and finally, the fun part. I'm giving you 4 functions. F of x is x cubed, g of x is the square root of x, h of x is x minus 4, and j of x equals 2x. And I want you to express a new function k of x equals the square root of x minus 4 all cubed as a composite of 3 of the above 4 functions, and give the domain. So you're going to tell me what f of g of h of j, h of g of f of whatever composite it is. And there's no formula for this, there's no magic trick. You just have to use your brains and you have to think. You have to use some trial and error. So what I do here is I start with the innermost part. And I say, okay, x minus 4, I'm probably going to use h of x, right? And I'm probably going to put that in the inside. And then I say, what am I doing to x minus 4? And I say, well, I'm cubing it. And so if I'm cubing it, the thing that cubes x is this one. So I'm going to put h of x inside f. So f of h of x, that takes care of x minus 4 and then the cubed part. And then I need the square root on the outside. So the square root on the outside, that's g of x. So I'm going to do g of f of h of x. And let's look at that. If I write g of f of h of x, I'm taking the square root, we're just going to plug it all back in, make sure it works, of x cubed, so x cubed, and h of x was x minus 4. That looks like what we wanted. We also need to give the domain. We can't take the square root of negative numbers, so what's underneath x minus 4 all cubed has to be greater than or equal to 0. Well, that means x minus 4 has to be greater than or equal to 0. Because if I took the cube root of 0, I'd get 0. So that means that x has to be greater than or equal to 4. So the domain for this is going to be 4 to infinity, including the 4. So it's g of f of h of x, and the domain is 4 to infinity. Let's try another one. Same f, g, h, and j, but now let's make 2x minus 12. All right, we're going to make 2x minus 12. So this one's a little harder. You have to think, all right, I need a 2, so I'm probably going to need the j. And then I need the x minus 12. But if I put in, let's say, this, I'm going to have a square root. I don't have any of those. I don't have any cubes. If I put the x minus 4 inside of the 2x, then I get 2x minus 8. That's closer to 2x minus 12, but it's not there. So what I can think about is, well, what do I need to get to 12? And I need 4 more. So I could do this minus 4, right? Plug it into h again, basically, and that would give me 2x minus 12. So I put h in the inside into j, but then I put that into h again. Let's double check it. H would be x minus 4, j would be 2x, and then h would be x minus 4. So that gives us 2x minus 8 minus 4 is 2x minus 12. That works. So we know it's h of j of h of x. And the domain of that, I can put any x I want in here. I can put any x I want in here. I could put any x I want in here. I don't have any square roots or even roots or division, so my domain would be all real numbers. Any x is okay for that. And one more just for fun. So you guys try this on your own. Push pause, and then I'm going to work through it with you. Okay, 2 root x minus 8. So I know I need this, because this is the only one with the square root. And it's being multiplied by 2, so I know I need this over here. If I did j of g of x, that would give me 2 times the square root of x. But I want it to be minus 8. So I'm looking at this and I'm thinking, okay, I need to actually put that in there somewhere and put it in before the j because I want to multiply that 4 by 2. So what if I did j of h of g of x? Let's see what that looks like. The g is the square root into the h, which was x minus 4, into the j, which was 2x. So if I do that, then I do get 2 root x, and I have to distribute the 2, so minus 8. So that works, j of h of g of x. And then I need to think about my domain. And the only limitation I have in here is the square root of x, which does carry through to the end. So that means that x has to be greater than or equal to 0, or 0 to infinity. So that's it. That's the end of this video. We will practice this a bit more in class, but doing these just takes practice. It just takes a little bit of thought. All right, I'll see you guys tomorrow.